Alright, I'm going to read from page 166. This will be a muscle contraction. Muscular contraction is a complex process involving numerous cellular proteins and energy production systems. The final result in the sliding of actin over myosin, which causes the muscle to shorten and therefore develop tension. Although complete details of muscular contraction at the molecular level continue to be investigated, the basic process of muscular contraction is well defined. The process of muscular contraction is explained by the sliding filament model of contraction, which is often called the swinging lever arm model of muscle contraction. For a historical overview of the sliding filament theory of muscle contraction, see a look back. Important people in science. Andrew F. Huxley developed the sliding filament theory of muscle contraction. Thank you, Mr. Huxley. Test question on Jeopardy. Overview of the sliding filament swinging lever arm model. I never heard that before. The general process or big picture of muscular contraction is illustrated in figure 8.5. Muscle fibers contract by shortening of their myofibrils due to actin sliding over the myosin. The result in the reduction in the distance from Z-line to Z-line. Understanding the details of how muscular contraction occurs requires an appreciation of the microscopic structure of the myofibril. Note that the heads of the myosin cross bridges are oriented towards the actin module. The actin and myosin filaments slide across each other during muscular contraction due to the action of the numerous cross bridges extending out as arms from the myosin and attaching to actin. The binding of the myosin cross bridge to actin results in the myosin cross bridge moving the actin molecule towards the center of the sarcomere. This pulling of the actin over the myosin molecule results in muscle shortening and the generation of force. The term excitation contraction coupling refers to the sequence of events in which a nerve impulse and action potential reaches the muscle membrane and leads to muscle shortening by cross-bridge activity. This process will be discussed step by step next. Let's begin with a discussion of the energy source for contraction. Oh yeah. Energy for contraction. The energy for muscular contraction comes from the breakdown of ATP by enzyme myosin ATPase. The enzyme is located on the head of the myosin cross bridge. Recall that the bioenergetic pathway responsible for the synthesis of ATP were discussed in chapter 3 and are re-summarized in figure 8.7. The breakdown of ATP to ADP and inorganic phosphate and the release of energy serves to energize the myosin cross bridges, which in turn pull the actin molecules over myosin and thus shorten the muscle. Note that a single contraction cycle or power stroke of all the cross bridges in a muscle would shorten the muscle by only 1% of its resting length. Because some muscles can shorten up to 60% of their resting length, it is clear that the contractile cycle must be repeated over and over and over and over and over again. 2 overs. Regulation of excitation contraction coupling. Again, the term excitation contraction coupling refers to a sequence of events that produce depolarization of the muscle excitation, which leads to muscle shortening and force production contraction. In the next session, we will provide a big picture overview of the excitation contraction coupling process, followed by a discussion of the events leading to muscle relaxation. Let's begin with the process of excitation. I'm going to hold off there. That's started on page 166, muscle contraction, and ending right here on 168. I'm going to be going into excitation. See ya.